All right, let's dive in. We're going to talk about something called Java conditional statements. Now, I know that sounds super technical, right? But stick with me, because this is the secret sauce, the actual logic behind how pretty much our entire digital world thinks and reacts. It's how it makes choices for us, literally every single second. I mean, have you ever really thought about it? How does an app know what to do next? You tap a button. How does your phone know if it should open a picture, send your text, or, pop up an error message? The answer to all of that is its ability to make decisions.
So let's get into how computers actually make these choices. And here's something that might surprise you. By default, a computer program is, well, it's kind of dumb. It's just a follower. It does exactly what it's told, one instruction after another, no questions asked. Its real power, what makes it seem smart, is when it learns how to break that sequence.
Yeah, most programs just run in a straight line. Line 1, then line 2, then line 3, and so on. We call this sequential execution. It's predictable, sure, and totally straightforward, but it's also really, really limited. A program that can only do this can't react to anything you do. It just does the same exact thing every single time. And this is the game changer, conditional statements. These are the tools that give a program the power to change its path. They let it stop, take a look at a situation, and decide to go down a completely different road. This is where the magic really starts to happen. So before a programmer even types a single line of code, they often map all this logic out visually. And the tool they use is a classic for a reason, the flowchart. You can think of it as the blueprint for every decision a program is going to make. Now, flowcharts have a bunch of different shapes for different jobs, start boxes, process boxes. But for what we're talking about today, there is one shape that matters more than all the others combined, and that's the diamond, the decision box. That diamond, the decision box, it represents a fork in the road. The program gets to this point, it stops, and it asks a really important question. And based on a simple yes or no answer, the entire flow of that program can take a sharp turn. And this quote right here really nails it. It might sound a little dramatic, but it is 100% true. Without the ability to test something, to ask a question and get an answer, a computer would be totally useless. It's just a calculator that can't ever change its mind. That ability to choose is everything. Okay, so let's take that flowchart idea, that blueprint, and turn it into actual Java code. We're going to start with the most basic, most fundamental decision-making tool in a programmer's toolbox, the if statement. The rule here is actually incredibly simple. Think of the if statement like a gatekeeper. It looks at a condition you give it. If that condition turns out to be true, the gate swings open and lets a specific chunk of code run. But if it's false, the gate stays shut. The program just skips right over that block of code completely. So how do we even build those conditions? We use these things, relational operators. This is basically the language we use to ask questions about how two values relate to each other. Is this number equal to that one? Is this one bigger? You get the idea. And here's the absolute key to all of this. No matter how complicated the question is that you're asking, the computer's answer always boils down to just one of two words, true or false. There's no maybe, there's no kinda. This is called Boolean logic, and it's what gives a computer its absolute, rock-solid certainty. Let's look at a super clear example. If we ask the program, if 10 greater than 4, well, is that true or false? Come on, you know this. Of course it's true. 10 is definitely greater than 4. So the condition is true, the gate opens, and whatever code we put inside those curly braces gets to run. But what if we flip it around? If 10 less than 4? Well, now the condition is obviously false, so the gate stays closed. The program sees that code inside the braces, but it just jumps right over it, ignoring it completely, almost like it was never even there. To really get why this matters, what goes inside that if block, let's look at a classic little logic puzzle for programmers, swapping the values of two numbers. Imagine you only want to do the swap if a certain condition is met. The logic inside that block has to be absolutely perfect. Okay, so here's the common mistake, the trap everyone falls into at first. We've got A is 200 and B as 300. In step 1, you might think, okay, I'll just set B equal to A. So B is now 200. But wait, see the problem? In step 2, when you go to set A equal to B, well, B is already 200. So A becomes 200 too. And that original 300, poof, it's gone, vanished. overwritten forever. And here is the elegant, classic solution. The secret is using a third temporary variable. Think of it like an empty cup. In step 1, we pour B's value, the 300, into our temporary spot to keep it safe. Now that B is empty, step 2, we can pour A's value into it, so B becomes 200. And for the final step, step 3, we just take the value we saved in temp, that 300, and pour it back into A. And just like that, the swap works perfectly. So that if statement is awesome for a single choice. But what if life isn't that simple? What if you have more than one possible path? What if you need to say, hey, if this is true, do this, but if it's false, do something completely different? Well, that's when we get a little more sophisticated. Meet the else statement. It's the perfect partner for if. It basically creates a simple two-way street. The program will run the if block if the condition is true, or it'll run the else block if it's false. It's always one or the other, never both, never neither. But what if you've got 3 or 4 or even more possibilities? For that, we use else if. This lets us build a whole chain of questions. The program asks the first if question. If it's false, it moves to the next else if question. If that's false, it moves to the next one and on, until it finally finds a condition that's true. Then it stops. You know, the absolute best way to think about this is a traffic light. The code first checks if the color is green. If not, okay, else if the color is yellow. And if it's neither of those, the final else is like a catch-all. It's got to be red, right? This structure handles lots of different situations in a really clean, logical order. And that order is super important. So let's zoom back out for a second. Once you really get this simple if-else structure, you start seeing it absolutely everywhere. It's like you've been given the keys to see the invisible architecture of our modern lives. Just think about it for a second. A login screen, that's just an if-else statement. A thermostat in your house is just constantly asking, if the temperature is too low, then turn on the heat. Those recommendation engines that know you so well, they're just a giant complex chain of if-else statements about everything you've ever watched. It all comes back to this one simple idea. And that kind of leaves us with one last big thought to chew on. Every single day, countless little decisions are made for us and about us by these simple coded rules. So, what does it really mean to live in a world where so many of our choices are being filtered through the cold, hard logic of an if-then statement? It's definitely something to think about.